Hello and welcome again. In this video, I will show you how to perform the diffusion analysis using the XIPline application. Again, select sequence type as the 2D GRE and then the scanner type. For now, I will keep it as Philips. Then we'll go to the image analysis tab and we will select diffusion from the analysis type drop-down. You can see here the proton images is graded out because we don't need proton images to segment the longer parenchyma, as we only look for the xenon signal. Once we do that, we will select the xenon data. You also have to specify how many B values for the diffusion images, as this is important if you're dealing with DICOM images, and then also to choose the acquisition order, which one is the inner lobe, the B value or the slice interleave. You can also do denoising, but I will skip this step for now. Once we have the xenon data allocation, then we will hit load or read the images. All right, here we have our images. And so you can see here through the slices. To see the B values images, you need to click on M-Slice Viewer, as I mentioned in the previous video, and then select the 3D from here. And then you can see here we have 4 slices. You can scroll through them, and then you can also scroll through the B value using the 4th dimension here. Okay, now we will move on to the registration. Since we don't have proton images, then we will skip the registration step for this analysis. Move on to the segmentation. Again, same method that I explained in the ventilation analysis: manual, threshold, and auto. However, since we only look for the signal, then the threshold method is the chosen method for the diffusion analysis. So I will go with that. And then I will start with the parenchyma, and then I will adjust the threshold as I see fit. Okay, now you can see that this threshold was a little bit aggressive. So we'll drop down this one a bit and redo it. Okay, now much better. If you're happy with that, then you can do that, or you can also edit the mask if you would like. Then for the ventilation, for the diffusion images, you do need to also do airway segmentation, but you have to do that manually, as I mentioned in the previous video. So we'll do that manually. There is no obvious airway here, so we'll skip. You can also segment area around the large airways here, but I will skip for this one. For example, here there is an obvious airway, so we'll take it out. All right, now we have our mask and then the airway as well. Okay, now once we have our mask, we are ready to perform the analysis. We start by providing the B values here. Since I have 5 B values, this is our default B values. And then you also have to choose the type of fitting. This is the easiest one, the log linear, there is a weighted linear, which is weighting the signal decay by the SNR based on the first p-value, and then nonlinear fitting, and as well as Bayesian. Bayesian takes a long time, but it is the most accurate one. So we will be doing the log linear for this demo. You can also perform linear binning method, which is not very common. However, here are the equation, the mean and standard deviation equation, based on the age. As you may know, that the diffusion measurements measurements are highly correlated with age, so you have to add the patient age here before you perform the analysis. And then if you have a different healthy cohort, so you can adjust to these equations for your healthy reference. But in Cincinnati, we have this our healthy reference equation. You can also perform the morphometry analysis. I added this one animal here. The code does exist here, but for here, we'll keep it for human. And then, of course, we have the cylindrical model and the stretch exponential model. You have to choose the D naught, the highest diffusion, and then the delta, which I mean the big delta, in milliseconds. Once we have that, then we will start the analysis. For the log linear and the linear binning method, they are very fast. However, for the morphometry analysis, it might take a few minutes because it will be doing lots of fitting, especially for two different models. All right, we're almost done. All right.
Diffusion analysis completed.
All right. Once it's done, we can look at the result under the result tab here and under diffusion here. Again, you can see here the mean and standard deviation of the ADC. We can look at the ADC map. You can also look at the ADC histogram compared to the healthier reference. For the linear binning, again, you can look at the ADC map. As well as the ADC histogram. For the morphometry fitting, you can choose any of these morphometry parameters. For example, here the edge. You can look at the map as well as the histogram. Similarly, you can look at the DDC or the LM. You can look at the map or the histogram. Again, the last option is an optional step. You can generate a report as we did in the last video, but I will skip this one. But for the ventilation analysis, that's all. And then under the diffusion analysis folder here, that you will have all the nifty images, the TIFF images, the histograms, the PowerPoint, the math output. So yeah, thanks for watching.